In this example, we are asked to identify a horizontal asymptote of each of the rational functions in A, B, C, or D. So the horizontal asymptote, that tells us what happens to the output as the input goes off to plus or minus infinity. So that's the end behavior of the rational function. And recall that this is determined by comparing the leading term of the numerator and the denominator of the rational function. And so in part A, the leading term of f is minus 10x squared. Okay, and just be sure that leading term means term with the highest power of x, not the first term. So we have minus 10x squared on the top, and we have the leading term of the denominator is 2x squared. And these two leading terms have the same degree. So when that happens, the horizontal asymptote is going to equal the ratio of the leading coefficients, which in this case happens to be minus 10 over 2, which is minus 5. So this means we have a horizontal asymptote at y equals minus 5. Okay, and so these horizontal asymptotes are given as an equation of a horizontal line, y equals minus 5 in part A. In part B, we have the leading term of the numerator is 2x, and the leading term of the denominator is 3x cubed. So this gives us a ratio of 2x over 3x cubed, and we see that the degree of the denominator is larger than the degree of the numerator. So when the degree of the denominator is greater than the degree of the numerator, we have a horizontal asymptote, and that horizontal asymptote is going to be at y equals 0. Okay, so in this case, we don't look at the ratio of the leading coefficients. Since the degree down here was bigger, as x gets very large, the value of the rational function is going to go to 0. For part C, the leading term of the numerator is x squared. The leading term of the denominator is x. And so the ratio of these actually winds up being x. And so when the degree of the numerator is larger than the degree of the denominator, as in this case, this means we have no horizontal asymptote. Okay, so as x goes to plus or minus infinity, the graph is actually not flattening out to a horizontal line. It is actually going to behave like the function y equals x. So in this case, we have what's called a slant asymptote, but since this is just asking us where the horizontal asymptote would be, we would say there is no horizontal asymptote for the rational function in part C. Okay, and lastly, in part D, we need to be careful here. So the numerator has a leading term of x. And in the denominator, it might seem like the leading term is 2x, but be careful. We're raising this to a power of 2. So 2x minus 8 squared is actually 2x minus 8 times 2x minus 8. And so the leading term of the denominator is the product of the leading terms of each of those factors. So we actually have a leading term in the denominator, which is 4x squared. And this is similar to what we observed in part B, in that the degree of the denominator, the bottom of the fraction, is larger than the degree of the numerator. So this means that there is a horizontal asymptote at y equals 0. Okay, so just to summarize what we did in this example, we look at the ratio of the leading terms. If the degree of the leading terms is equal to each other, then we get a horizontal asymptote at the ratio of the leading coefficients, such as in A. If the degree of the denominator is larger than the degree of the numerator, so if the bottom has a larger degree than the top, like in B and in D, then we get a horizontal asymptote at y equals 0. And the other possibility that we saw in part C is when the degree of the numerator, the top, is bigger than the degree of the leading term in the bottom. And this is the case where no horizontal asymptote will exist.